Edexcel Summer 2014 C2 paper, Hints and Tips, Part 2. Right, question 7, pretty simple trigonometric equation. Okay, what I would do first of all, divide by 9. So in fact I might even do it up here. Hold on, I'm just going to move this over so I've got a bit of room here. So I would go, well, sine of theta plus 60 equals 4/9. I'd then go theta plus 60 equals sine to the minus 1 of 4/9. Alright, remember, put your calculator back in degrees mode because you're working in degrees, and you should end up with two answers. Now one of them will be a negative answer, so you've got to do 360, well, negative 30 for example is 330 degrees, isn't it? So there you go, you just got to be a little bit careful with that. Now part 2, so that's part 1. I'll leave you to finish that. Remember, two answers is what you want. Okay, for part B, not part B, we're not having part B in this, it's part I should say. So part I, okay, says this. Now I'm going to turn tan x into sine x over cos x. Alright, and that gives me this minus 3 sine x equals 0. Alright, I'm then going to multiply through by cos or cosine. Alright, so we get 2 sine x minus 3 sine x cos x equals 0. Right, I'm then going to, well, I can factorise out sine of x at 3 cos x, which means if I divide by sine I get 2 minus cos x equals 0. Sorry, 3 cos x, don't know where the 3 went there, and you should be able to solve that from there. Again, you're going to end up with a couple of answers. It's in radians this time, so make sure you're in radians mode on your calculator. Okay, so sketch the graph of this. Now you should know that these graphs here have a certain shape, don't they? So you should know straight away, okay, that you've got something that looks like this. I'll do it in blue so it stands out. It's going to tend towards the x-axis, goes up here, and that's going to be 1. They always cross at 1 because anything to the power 0 is 1, isn't it? So there you go, there's your sketch, 2 marks, job's a good one. Right, so that's part A. Part B, however, right, is a little bit, well actually part B is much easier than you think, perhaps. So if I say that y equals 3 to the power x, I can rewrite this as, where are we, y squared minus 9y plus 18 equals 0, and you can factorise that, and eventually you'll get two answers. One's a pretty simple answer, one you'll have to use logs. Okay, so question 9, we've got to find, for part A, find the exact value of k, and that's the centre of the circle. So what I'm going to do, I'm going to try as neatly as possible, draw a straight line there. I've got a right angled triangle. Now I already know, and I'm going to have another right angled triangle here. Okay, I know that's 11, right, but if I can find, I'll call it, well, what should I call it, A or something. Alright, so for part A, I'm going to do this sort of thing. So A equals, don't know why I did that there, 6 root 5 all squared plus 4 squared. Now, stick that in your calculator, you should end up with 14. And I know that this is 11 along here because it tells me that the centre Q is at 11 something. So I know that's 11. I've got to work out B here. Alright, and that's, well, actually, what am I talking about? B. Give me a letter already. I've got to work out K here. This is K there. Alright, so you should be able to do that with Pythagoras. Now once you've got the centre. Remember the equation of a circle is x minus a all squared plus y minus b all squared equals r squared. Alright, where your centre is AB and your radius is r. You should be able to do that pretty successfully. Right, okay, final question. Looks horrible. Not too bad actually, it's just quite long. So it says show that the volume of this. Now you should know volume of a prism is area of the face. Now the area of the face, here's the cross section here, and you times it by y. So you should know that, and I'm going to have to squeeze it in, I haven't got much room on here. The area of a trapezium is the sum of the parallel sides divided by 2 times the height, which is 4x. Alright, so that's the area, times that by y, and that equals 9,600. That simplifies to give you the answer that I give you. Right, hence show the surface area of the letterbox is this. Now that's just, to be honest, I'm not going to do a huge amount there, because all you've got to do is find the area of all the sides using what you've got in part A as well. So there you got 2 trapeziums and a whole load of rectangles. Right, add them up. I'll give you a clue. Oh, I know, they tell you what the answer is, don't they? There you go. So you know that's what you're looking for. Alright, now for part C it says use calculus to find the minimum value of S. So if I've got, so I'm going to do part C up here. So if I've got S equals 60x squared plus 7680x to the minus 1. Alright, I'm going to do ds dx. I need a gradient function, and that's going to give me 120x minus 7680. 7680. Alright, to x to the minus 2. Alright, now so there we go, and we're going to make that equal to 0. Alright, that will give me the point on the minimum. So if you ultimately what you get is 120x equals 7680x to the minus 2. Solve that, get a value of x, and then substitute that into your function here to find the value of s. Now for part D, all you've got to do is then find d2s dx squared, put in your value of x that you found in C, alright, and work out whether it's positive or negative. If it's positive, it's a minimum. If it's negative, it's a maximum. So there you go.